Hello and welcome to today's webinar, Virtual Twins Making Better Decisions Faster. In this session, we're going to have a panel discussion on using virtual twins to deliver high quality products on time. My name is Chad Jackson. I'm the CEO and Chief Analyst of Lifecycle Insights, a research, advisory, and publishing firm. And we're going to have a great panel of experts today that we're going to have a roundtable discussion with, and let's meet them now. First off, Brent, why don't you do a quick introduction for yourself?
Hi, I'm Brent Vorst with Kinetic Vision. I'm a team lead in the modeling simulation group here. So doing all the stuff from stress strain, thermal analyses, fluid flows, automation processes. So pretty much end-to-end modeling simulation support.
All right, thanks so much, Brent. Next up, we have Prashant. Why don't you give an overview of yourself as well as Dassault Systèmes?
Thanks, Chad. My name is Prashant Mysore. I'm a lead for global strategic business development for manufacturing and supply chain within Dassault. Just to give a brief introduction about our company, Dassault Systèmes is the 3D experience company, as most of you know. We are a purpose-driven company. We think the progress and innovation in terms of balance and impact, harmonizing product nature and life is at the heart of everything what we do and what we bring to the world. And we have about 20,000 passionate people across 140 countries. And Dassault Systèmes has been the largest PLM and 3D experience market share with more than 270,000 customers, along with 12,600 selected partners. And we proudly say that we've been the catalyst and enabler of world's greatest industrial transformation. And every decade, we have helped manufacturers to disrupt how products are designed and made and to rethink their whole manufacturing and supply chain methods. And we are in the 5th stage of our journey. And as you see on this chart, the first stage of our journey started way back in 1981 with a 3D design. Then we moved on towards digital mockup, which is about digital twin. And Boeing 777 is one of the first ever digital twin created using Dassault Systèmes technology. And then we introduced the product lifecycle management as our third innovation major change by introducing the lifecycle management along with representation of time. And then we went to the 4th stage with the introduction of 3D experience platform to bring in perception and emotion for all the products and manufacturing processes. The 5th stage of journey, as I said, virtual twin experience of humans. It's about modeling and simulation of bringing in information together like biosciences, material sciences, and information science data all together to bring in the virtual twin experience of human beings to bring in all the innovative processes, including some of the vaccines development which you've been actually seeing. Okay, and then we also have customers spread across 11 different industry verticals, and we have also added 12th industry. We have about 250,000 enterprise customers and 25 million users across 11 plus 1, 12 industries in 140 countries. And our customers range from major accounts like original equipment manufacturers to startups to governments as well as individual users. And we provide solutions for all 6 sectors of the economy, from mass production to retail to high tech to construction, mining, and even smart cities.
Great. Awesome. Arvind, why don't you go ahead?
Yes, thank you, Chad. Good morning. My name is Arvind Krishnan, and I'm a senior analyst at Lifecycle Insights. Lifecycle Insights is an advisory and research firm, and we work primarily in the area of design all the way to manufacturing. So look forward to having a great discussion today. Thank you.
Great. Awesome. Thank you so much. Well, let's jump right in. Let's get into our first topic. So first off, there's lots of movement in terms of improvement initiatives in engineering. We're seeing lots of activity on that front, and the virtual twin is it's a component of those initiatives that we're seeing a lot. But before we can have a discussion around what it is and what value it provides, we should define it. So let's jump into that first, and let's get everyone's perspective. So Brent, why don't you kick us off here? What is a virtual twin, and how do you define it?
Yeah, that is a very broad term, I would suppose. It can be anything from, like I was saying, modeling and simulation, some kind of computer simulation model, to a virtual reality environment where you immerse somebody into an environment and have them play with a digital copy of something in real life. It's a lot of, it could be a lot of things to me. So usually when someone asks for help with a digital twin, I usually approach them with this kind of a question as well. Like, what would you consider a digital twin here? Is it more real physics, or is it more real feel kind of thing? It's very up to interpretation, but it can cross, probably a dozen or so different technologies, I would say.
Yeah, great points. Absolutely. Let's go around the horn. Arvind, what's your take here?
Sure. As Brent said, this is quite an interesting as well as a confusing topic. First of all, let me just say that we might interchangeably use virtual twin and digital twin, but for the purpose of this particular conversation today, we'll assume that they are primarily the same thing. So let me start off with just laying out some of the characteristic traits of what a digital twin or a virtual twin should be. First of all, it is some sort of a digital model. Now, as Brent said, that could be anything from a simulation model to a CAD model, but there are some traits that it needs to follow. First is, I would say, it should be driven by some sort of sensor. So there is a connection between the real thing and the virtual. And the real has some sensors which transmit some data back into the virtual. So that's the first thing. The second is you can have any sort of digital model that actually has the ability to take in this sensor data, and not just that, do some processing on the sensor data so that it can have some predictive capabilities. And now this predictive capabilities, when used by executives, can actually offer them insights, and they can use these insights to improve their current operation. So that's really, from my point of view, some of the characteristics of a virtual twin. Has to have sensor data, has to have some sort of model. That model needs to take this data, process it, and deliver some predictive insights.
Great. Yeah, good perspective. Prashant, what's your perspective here?
Thanks, Chad. And I think I slightly have a different opinion to Arvind. Virtual twins are not static compared to the digital twins, which may be not fully dynamic, I would say. And it could be a responsive system connected between physical and digital world. Whereas virtual twins are an uplift to digital twin. In essence, it can integrate to sensors. Arvind, you beautifully articulated, and you bring in artificial intelligence, you analyze the data, and you bring both the real world and virtual worlds together to have a meaningful output of various processes. It's imaginative, it's immersive, it can be collaborative, as well as it can be predictive and prescriptive as well. And Arvind, you nicely pointed out as well, what do we do with the real world? You drive the real world with the virtual world through analytics, bringing in AI and ML based on IoT and structured and unstructured data. And then you'll also do a knowledge management. And obviously, due to agility requirement these days, obviously the virtual twin should be capable of handling dynamic data for agile planning and execution management as well. So in a nutshell, the virtual twin or virtual twin experience is an executable virtual model of a physical system, which brings in learning and experiences from the real world process to update the twin model continuously for effective optimization.
Very good. All right, those are all really good perspectives, and I hope it helps everybody watching and listening to our session today kind of get their arms around it first. That's a really important aspect. But as we go, I'm sure each of you watching and listening out there might have questions, and we will have a Q&A session at the end of the session. So make sure to enter your questions into the platform, and we will get to them as soon as we can. And with that said, let's get to our second question. This is all about what's driving companies to kind of pursue these efforts. We talked about what a virtual twin is, but what's driving companies to actually pursue it? Brent, let's start off with you again. What's your perspective?
Yeah, we've seen a lot of companies come in with trying to get their feet wet in using virtual twins. And usually comes down to a few different things. One of them is just the speed at which they need to manufacture things, at which they need to produce products. You know, you go through your traditional process, and you continually tune your manufacturing processes and get them better and better. And eventually, you hit a wall, or you know, make a new product, and you still need to have the volume output, but you have the improvements you have to incorporate. And it's really expensive to do that. I would say manually, or without in a physical process, without a virtual process. Especially if you have to shut down a line, you have to meet volume, that kind of stuff. So speed at which you produce products is one of the major drivers for why people tend to use digital twins or virtual twins. It helps them speed their process up. They can optimize quicker, get to a solution, and launch it faster without hindering their increasing their downtimes. Another reason is cost. Like I said, you know, those downtimes cost a lot of money, a lot of time. It costs a lot of resources, you know, over time. If you have to continually shut down the line to implement new configurations or tweak things, it costs people a lot of money. So speed at which you need to produce things, costs, those are two of the major things. And one that's kind of like lurking in the background is just almost like a fear people have that they're going to almost be left behind. Things have changed a lot in the last few years. So that the speed at which technology is growing, at which people are implementing their technology into their manufacturing processes is kind of rapid. It's rapidly changing. So there's a lot of people that are just like, you know, we see this happening. We see others have this. They're using it with success, and incorporating modeling and simulation into the engineering processes. And it's really worked for them. So they kind of want some of the same things, so they don't get left behind in the manufacturing world, basically.
Yeah, really great points. Thank you so much. Prashant, what's your perspective here?
Yeah, there are multiple factors. You know, if I start from like we say post this disruption, COVID disruption era, there are requirements for remote employee collaboration, as we've been seeing during these days of disruption. Obviously, nearshoring and onshoring of manufacturing, which is actually pushing a lot of manufacturers to really adopt different strategies, bringing in flexibility and agility in the production processes due to change in customer demand and due to change in requirements. Workforce automation. Obviously, people who have had a lot of automation have ensured their business continuity even during this time of disruption. And obviously, strategies around changes in raw material prices, and those changes are also really forcing manufacturers to look at different possibilities and aspects. So this is where digital twins or virtual twins will really play an important role in helping bringing in agility, business continuity, employee safety and security, remote collaboration and all, and even to be on an innovation strategy or innovation journey to meet to change in customer demands.
Good. Excellent. Thank you so much. Arvind, what's your take? What's driving companies to adopt virtual twins?
Chad, I think excellent points made by Brent and Prashant. What I want to bring is a research done by Lifecycle Insights earlier in the year that really talks about some of the drivers. So we asked companies, engineering executives in manufacturing, like what is driving them to improve their manufacturing process? And this is what the data tells us. And obviously, a lot of it is in alignment with what Brent and Prashant said. So let me just go over some of the things that I can append to what they said. So let me start with the importance of sustainability today in today's world. I mean, that can't be overstressed. We just concluded the COP event at Egypt, and I guess every executive, along with every national leaders, are really thinking about how sustainability can be influenced. And manufacturing, as you know, is also an important component where there is a lot of energy being used today. So obviously, companies are cognizant of this fact, and they believe that they can transform manufacturing at the same time, be more sustainable in their operation. So that's one. I just want to add on to what Prashant said. The COVID disruptions have really made people in the manufacturing organizations think about how they can better handle future disruptions. Now, future disruptions does not need to come especially from pandemic. I mean, future disruptions, we are still seeing some sort of a war brewing in a different part of the world, and there is a lot of things that can affect future difference. So companies have to be nimble and they have to be flexible. And that means nearshoring, offshoring, that means improvement in their processes that they have today. But all of this are driving companies. There's no one driving factor, Chad, if I may say. There's a plethora of factors that are driving companies. And I think every point that was made here and all of them have been brought out in our studies as well. So these are some of the key challenges that companies are facing, and they would like to tackle these challenges by improving their management.
Okay, good perspective. Yeah, thank all of you. Let's talk next about value that companies realize from these efforts. Now, of course, you can realize all different types of value from these kind of improvement efforts. They can take many different forms, and different companies can seek out different types of value from these efforts. Primarily, what types of benefits are we talking about when we look at virtual twins with respect to manufacturing? Prashant, why don't you get us started there?
See, we talk about digital twins or virtual twins. It's all about improving flexibility, improving efficiency, and bringing in sustainability angle into the production and operations, right? What we could do with virtual twins is all about simulating assets. It could be robots or machines for managing efficiency of production. You can also design factory, production facility, or even a warehouse or a supply chain or a distribution center in a sustainable way towards net zero effects. And then you can also optimize throughput of your production facility using reduced waste. And of course, we can bring in lean manufacturing principles. There are about 15 lean manufacturing principles we can actually validate and simulate, even adopt in a day-to-day basis using virtual twins. And obviously, we're all talking about circular economy towards ESG goals and sustainability goals, reduce, reuse, and recycle, and how well virtual twins and simulation models really help with achieving some of the sustainability goals is an important aspect as well to consider. And obviously, since we are working on digitalization of the whole manufacturing process, be it product, process, and resources, and systems, and models, and all of them will actually bring in a lot of transparency in terms of consumption of resources. It could be power and water or different consumables, or even value-added and non-value-added activity validation. So these are some of the things which we can actually have a much better control through virtual twin experience.
Okay, good, excellent. Arvind, what's your take here? What are companies seeking in terms of benefits from these efforts?
Sure. When an executive goes for a manufacturing transformation, there are key ROIs that they are looking for from a company perspective. I might call that key metrics, let's say. Now, the biggest challenge that companies face is when they adopt a certain practice, a new manufacturing practice, say like a virtual twin, they are looking for some results. Now, the biggest advantage that I see that virtual twins can help these companies is how can they monitor these key metrics and compare them to what was originally envisioned. If I want to improve my production by 25%, am I improving my production by? Now, companies have always done that, but after the fact, if you look at it, they could get these results at the end of the quarter. They could get these results at the end of the year, and they would say, oh my God, I met this or I didn't meet this. But that's no good today. What virtual twin enables them to do is they can monitor these key metrics on a continuous basis. As a result, the companies don't have to wait till the end of the quarter, end of the year to see, oh, I need to make course corrections, but I can make course corrections on a daily, hourly basis if I want. So that's the power, I believe. It gives executives instantaneous measurement that they were not able to get so far without this concept of a virtual twin. And now with these key metrics, they could clearly see if they are going on the right course or are they off by certain things? And if they are off, and as Prashant said, these virtual twins are actually smarter today. They might even guide you as to how you can come back to the course that you are destined to go, right? So I believe that's the power of virtual twins, which companies can actually benefit.
Good. Yeah. Thank you very much. Brent, what about you? I'm interested to hear what you think on this topic.
Yeah. Yeah, like I mentioned earlier, I guess, the ability to update your manufacturing processes, optimize them, or optimize the product of which you're manufacturing within the process is without a doubt one of the biggest impactors within the industry right now. And being able to do that without, like I said, impacting your production schedule is a big deal. So we've had people come in with this problem multiple times, and there's been a couple of times. I'll give you a couple of examples. There's been one customer came in and they had a product that they were conveying down a manufacturing line. They're seeing all kinds of problems with the conveying of it, and it would a product would fall or come off the line or whatever, and it would basically shut down the line for a minute or two, and then they'd have to fix it, go manually fix it, and restart the line back up, and it would just breed more problems. And so, first thing we did was you collect the data, you figure out what's going on, and you can take that data in, train a machine learning model if you need to, or just analyze the data in a smart way and show where these problems are originating from. And then you can go ahead and implement, like we implement an automation or a vision learning system that can actually warn or detect when these problems occur when they're starting, and alert the workers in the plant, the manufacturer, that this is about to happen. You have about 90 seconds, 2 minutes to fix this problem. This bottle's coming down the line. You need to fix it before it reaches this next machine. If they can do that, and then they stop a downtime. So just unique solutions like that. Or we had another person come in and they had a problem with their product was breaking under a load that it needed to meet. So they came in and we try to figure out what geometry changes can we do to improve this product, improve the way we manufacture it. And just the matter of going through the process of creating a virtual twin, of gathering the data needed as input for these virtual simulations, you learn a lot. So one thing they learned is just the way that what they're manufacturing is not actually what they thought they were manufacturing. So what they we run through, we're in put CT scans on it, so full 3D geometry of the as manufactured product. And what they're manufacturing is not quite what they're manufacturing. The masks they put on to measure thicknesses and critical dimensions was kind of almost tricking them. And so we were able to find ways to just move material around within the product and actually take some material out. So it actually ended up being lighter and cheaper, just through understanding how the product was being made. And then we can go ahead and simulate and figure out what's the most optimal way to produce this product. So there's all kinds of variations on this, but those are two that stick out in my head, I suppose.
Oh, it's great. Yeah, good examples. That really kind of brings it home. Thanks so much. So let's talk about, the reality is that these types of solutions rarely sit in isolation. There are other types of solutions that are being used, especially in a manufacturing environment. We talk about IoT, talk about automation. So a key question to kind of look at here is, how do these efforts kind of integrate into those existing real world type of technologies? Arvind, why don't you get us started on this one? What's your perspective?
Yes, Chan. The whole idea of being able to digitize the reality is what we are talking about today. What does that mean in a manufacturing perspective? We could say that you could either digitize the process, you could make it virtual, or you can digitize the entire plant or factory. Any of these things are actually possible, right? But the idea is to understand how the actual behaves, right? The virtual by itself does not have a whole lot of importance or meaning if the actual does not perform, or it's somehow tied to the reality of it. So does it behave normally? These are some of the important questions that these things answer. That's where the integration with the real world comes into play. So for that, you would need to be able to, as I want to reiterate again, you would be able to need to capture and use the data from the actual facility, the actual. Now, that itself is not all that easy. What data to capture? How often should I capture? How should I capture? And how should I relay it back? These are very important questions that need to be answered before someone can actually embark on this journey, right? Once you get the data, what do you do with it? Like, I mean, we have seen many instances of companies having reams and reams of data just sitting there, right? I mean, that defeats the whole purpose, right? Should I be just looking at data in isolation, or can I now look at with the digital model that I actually created? And that's where the value comes in. Could I superimpose the real with the virtual? Right? And then what? Once I superimpose, now I need to take action, right? Because if things are going fine, you can pat on your back. If something is not going fine, or you predict that something will not go fine, like Brent just said in the previous one, can I make stoppages? Can I make meaningful decisions so that my manufacturing operations will continue smoothly, not just today, but ever in the future? So I guess that's where the connection with the real world through IoT, through automation, any of these technologies, that's where the value is how do I use the data that comes?
Great. Excellent. All right. Prashant, you're up. What do you think?
I think, yeah, alluding to what Arvind, you mentioned, you have various technologies, right? So one end of the spectrum, you have IT sources, you have ERPs and warehouse management tools and supply chain tools and all, and the PLM at one end of the spectrum, they're all information technology sources, and 3D model and simulation. And on the other side, you have OT technologies like sensors and RFID tags and data visualization tools, Swiss logs, and of course, data from AGVs and ASRS tools, and even machines and all are coming. So somebody has to contextualize it. Somebody has to make sure that both the IT world and the OT world work in tandem or contextualized way, so that you can really model the whole business process and control the real world through a virtual world through all these connections like IoT data reading, make a decision support or decision automation based on these data, and then ensure that your production is on dot and the performance is monitored in a virtual way, so that your real world operations are not interrupted. Okay, so this is the contextualization which we are talking about. And here you have your planning, you have your scheduling, well aided by your simulation mechanisms. Of course, your materials are optimized, manpowers are optimized, and even the measurements. And all of them, like man, material, methods, and measurements, are all optimized through a collaboration model, wherein all your all various departments, all key personnel in the departments, even external enterprise, are collaborating for day-to-day problem solving, ensuring business continuity within the manufacturing and supply chain as well, and giving right data at the right time for manufacturing team. So this is exactly the contextualization which we are talking about.
Good. Great. Thank you so much. Brent, what's your perspective here? You're dealing with this on a daily basis. I'm really interested to get your perspective.
Yeah, this is integrating virtual twins back into reality is a big deal for a lot of people. Obviously, it's important what you simulate mimics, or what it predicts actually happens in real life. What you are simulating is reflective of what's going to happen when you go into the plant, right? So we tend to do a lot of physical and digital and mix them together, right? So one of the things we tend to do is, if there's easy data you can collect from the real world, from the manufacturing plant, or just collecting data on the processes themselves, so product manufacturing, there's easy data you can just collect and grab, do it. It's important. Take it. Take that data, it'll help you learn things just in its own within its own nature. It'll help you learn about what you're doing. But also when you combine that with the virtual data, it becomes really powerful. So like like I said, you collect that easy physical data, you'll analyze it, and you'll notice there's gaps in the data, that stuff you're not collecting, right? There's things that you can't measure physically really easily, or at all really. So what you can do is you can then introduce that virtual twin, and you can fill those gaps in virtually. And now you have a really cohesive data set, a really rich data lake almost, where you can come in and make more influential decisions. You can make more impactful predictions. And basically you can increase your production or optimize your process a little more easily, and you can more automate the process. I would say you can see what the data is saying, and you can then go implement automated solutions, because you can predict what's going to happen next, and you can go ahead and validate the virtual twin, and then you can go ahead and implement physically a little more easily, because you have all that data to make the right decision the first time, basically.
That's great. Yeah, no, that's a really interesting perspective, especially augmenting real world data with digital twin data. I think that's a really compelling type of concept.
Yeah, they don't compete with each other. They go hand in hand, and they really support each other.
Yeah, totally makes a lot of sense. Good. All right, quick reminder, if you have questions, and I'm sure, we're talking about a lot of new topics here. This is a complex set of issues. If you have questions, please enter them into the platform, and we will get to them during our Q&A session or as soon as we can. Let's shift to talk about security. There's a myriad of threats in the security space today, especially when you talk about IT and even OT. And it's important to discuss that. So number one, I'd really like to hear from you all. Where does security fall in terms of priority for manufacturers? And then how does it relate to the virtual twin? And Arvind, I'm going to throw this one your way first. What's your perspective?
Sure. Yeah, I'm going to refer you back to the research that Lifecycle Insights did earlier in the year, where we talked to manufacturing executives to really understand what are some of their reasons for using cloud solutions. And clearly, there are other reasons such as cost and accessibility. But if you see, improved security is also one of the salient reasons that people have put out. Right? So the research says that manufacturing companies are indeed worried, and they are aware of the security issues. Now, when it comes to virtual twin, it's interesting because there is an aspect of cloud now involved here, right? Just by itself, manufacturing plants need to be secure. There is no doubt about that, because you don't want external bad actors to actually cripple your production. So that's a real fear for every particular manufacturer. But now, when you bring in this virtual twin into place, there is an extra layer of cloud that happens. And the funny thing is, most people are apprehensive about cloud. They should not be. And that's really the point that I would like to bring them. Security is extremely important for manufacturing companies, but many of them somehow have this misunderstanding that cloud may not be secure enough for them, And that's where I think a lot of our research and talking with executives come into play. In fact, if you understand the technology well, cloud is by far one of the most secure thing that you can implement your manufacturing or virtual twin strategy. So I do want to bring that into perspective here. However, the adoption of virtual twin on the manufacturing side is way slower than the adoption of virtual twin on the design perspective. This is another finding that we have also found over the years at Lifecycle Insights, right? Why is that? There is a fear that their manufacturing could be attacked and the plant could be stopped. Now we are really thinking about real products not being shipped out. So the design fear is more a little about, will I lose some time in designing, or will I lose some intellectual property? These are important, but nothing as important as the real product not being able to be shipped out to the customers, right? So that's really, I want to bring all the perspective on security here. Our findings say that security is important. We also want to stress that the virtual twin, which is by far using a lot of cloud technology, is actually secure, and the adoption can be accelerated from the manufacturing.
Good. Yeah, that's great. Thank you, Arvind. Brent, what's your perspective on the security issue and virtual twins?
Yeah, I don't have a ton of input on this one. I know it's a big issue. We've seen a lot of people concerned about the same types of things that Arvind was just describing. But I mean, in general, I've seen a lot of big companies that are able to have the means, the funds to deploy and to manage these large like in-house structures where they want to like manage their own security and that kind of stuff. But that, like I said, that can be expensive. That's hard to manage. You have to have a lot of resources to do that. So I have seen that cloud really has been a really good way for small, medium-sized companies to more economically and get in the game, really, to use these types of technologies, to use virtual twins a little more readily, like a little more off the shelf, than having, you don't have to go and make this big internal structure for yourself before you can do this. You don't have to make that huge investment. You can do this stuff now in a secure way, like Arvind was mentioning.
Good. Yeah. Very good perspective. Thank you. Prashant, what about you? What's your take here?
Dassault, we in Dassault Systems have been providing cloud-based services ever since the advent of this 3D experience platform way back in 2012. And we have built the full cloud ecosystem on 3D experience cloud platform. And obviously that enables our clients to benefit from services which are flexible, scalable, and resource optimization, total cost of ownership, which beautifully articulated by Arvind and Brent anyway. We have made our mission to support most of our clients who are on cloud with a lot of trust and reliability. It's not only trust and reliability, but you need to have some of those standard practices as well, right? We have information security and privacy management system, which is a standard protocol, which we call this as ISPMS. That is ISO certified 27001, 27001, and ISO certified 27701 as well. And these are subject to routine auditing, and this security and privacy management system is based on core values of confidentiality, integrity, availability, and accountability. These are some of the aspects which we manage effectively well using 3D Experience Platform Cloud System as well. And we also addressed some of the core aspects of privacy and compliance practices, and which are integral to this ISPMS standard protocol. So these are some of the technical aspects which we actually bring into the table, along with obviously managing data security and data breach. Chad.
Good. Yeah, thank you. It's good to get a perspective on how Dassault is addressing this type of threat. Okay, let's talk about other key enablers for these types of efforts. What we've seen is, typically just adopting technology by itself isn't enough. Just making changes to people and process is not enough. You need to have a synergistic effort across both. So, and that'll determine if you get value out of that improvement effort. So when it comes to virtual twins in manufacturing, what are the most important enablers of change? Prashant, we're going to stay with you on this one. Let's get your perspective first.
See, some of the enablers, we have also defined based on our experience working with Laven. Now we address 12 different industry verticals. We have a good experience in bringing in best practices from one industry to other industries. Like example being construction is adopting some of the manufacturing practices like lean manufacturing to lean construction and all. There are a lot of these cross-pollination things are going on. So having said that, we have established 5 core methodologies of the business processes, which are modeling your business process. It can be a 3D model or a business process mapping or your supply chain model. Any of those models, well defined using our modeling philosophy. And obviously, once you have modeled your business process, you need to collaborate within enterprise, within the departments, and across value chain with your customers and even suppliers as well. Collaboration is the key thing as a part of this virtual twin process. And the third one is optimization. We need to optimize workforce, optimize schedules, optimize supply chain. All of them are integral part of the whole virtual twin process. Obviously AI will also come into picture when we are trying to optimize the whole data, right? And then execution management. Once you're done the optimization and collaboration, obviously somebody has to execute the process. This is where the virtual world and the real world work together, and you have to have an autonomous work order management, overall equipment effectiveness of various machines, and the standard operating procedures of workers, and all of them are digitalized along with continuous data monitoring coming from IoT data, both structured as well as unstructured data from various sources. And how do you actually view these data for day-to-day production management? So these are some of the aspects. And the fifth one being innovation. Innovation through what-if analysis and simulation, innovation through AI-driven optimization, and innovation through this contextualization we spoke about, how we contextualize IT and OT world, and then bring in the data perspective for modeling and simulation is an extremely important thing. So these are the 5 processes which we, based on our experience in 12 industry verticals, which we normally propose it to our customers and partners.
Okay. Yeah, good perspective. Thank you so much. Arvind, what have you seen? What's your take here?
One of the key enablers, I think, is the merging of IT and OT. How well a company merges these two really determines their success. Now, here is where, again, the power of data in improving manufacturing comes into play. The advantage that manufacturers can enjoy by digitally modeling their physical setup will be compounded if the real asset data actually benefits from this digital model, and vice versa. And the digital model benefits from the data. So that's a key enabler. That's what many people say, merging of IT and OT. The data comes from sensors, and then there's a digital. So I think that's a critical enabler. Now, if you want to look at some tactical enablers other than that, how can I merge IT and OT? Right? That's another question that people would be thinking about. How can I merge the digital and the physical? So again, it goes back to some fundamentals. What are the important data I need to collect? How do I collect them? How do I convey it back to the digital model, right? And now, after conveying those data back, what kind of processes, what kind of simulation should I run on the digital model using this data? And what kind of predictive capabilities do I get back from these data, right? And based on that, executives can take decisions because they've always been taking. Manufacturing is not new. So they know if things go wrong, executives know very well what to do. The power now of merging IT and OT is they can be alerted things might go wrong before they actually go wrong. So that's really, I would say, a dream for executives. It's like saying day after tomorrow, there could be a problem here. Oh, no worries. I know how to get that. I'll make sure that the problem doesn't occur. So I think the key enabler there, I mean, Prashant has already really brought out really how to marry IT and is, in my perspective, a very important thing that companies need to look into.
Good. All right. Excellent. And Brent, what's your perspective here? What are other key enablers?
Yeah, I mean, I mentioned this earlier. Typically, one of the biggest things to get in the game here to really get benefit from modeling is just to get you have to have a good understanding of what your manufacturing process is, what it's doing. Basically, it helps you get a hold of it. And if you can figure out what your manufacturing process is doing, exactly how it works, we have a goal in mind of what we want to achieve, what we want to improve, optimize, that kind of thing. Those are a couple of the key things you just got to come in with, right? You don't have to come in with a full understanding. You have to come in with, down to the, deep details of every process. You just got to know, like, this is what we want to learn. We want to learn more about a process, and we have a goal to fix this problem or to improve this process. And so I mentioned earlier, creating a simulation, creating a model is or validating a model even is an important step in just gathering that data, because a lot of the data that you gather to create these models is the exact same data you would use to fix them or to diagnose them in the physical world. So you're collecting the data for two different purposes, essentially. It helps you learn about what your physical process is doing, and also helps you build that virtual. So when you see that problem and you identify that problem, you can go address it virtually before you physically try to fix things, before you try to deploy things into the real world. I can't tell you how many times I've had people come in and we would, start this process, and they'd be like, "Wow, I did not expect that thing to be happening in my line. I didn't know that was happening," or it'd be like, "Huh, I didn't know that was a problem. I didn't see that over there. That's not something you just pick up on when you're manufacturing, 300 parts a minute. It's not something that you can just grasp and see with your own eyes." And so gathering that data to create these virtual twins and create these models is really an important first step, just to understand really what your manufacturing process is doing, and then you can go improve it.
Good perspective. Yeah, it's always to hear the stories from what's happening kind of on the front lines, where this is actually the rubber's meeting the road.
Yeah,
it's good stuff. So okay, so we've defined the virtual twin, right? We've talked about what's driving companies to do it. We talked about key enablers. Let's talk about how you get started. What are some initial steps? What advice do you have on that front? And Brent, let's stay with you. What's your take?
Yeah, I'm just gonna mirror what I just said. Coming in and just with the idea that we need to understand our process better, and we have this goal that we want to achieve. That's all it takes to get started. You want to learn, you want to improve, and you have a goal, and we want to achieve that goal, right? If you want to get started in this thing, the first thing I would suggest is to talk to an expert and to start small. I've seen a lot of times where people come in and they try to bite off too big of a bite, or they don't come in with a good plan, or don't come approach someone who's going to make a good plan for them and help them, and then they end up having a bad first experience, a bad first exposure to modeling simulation, and then it leaves them thinking that the technology is just not there. It's not ready for my problems. My problems are too complex, and that's probably not the case. There's been modeling simulation and virtual twins can cover pretty much any technology out there right now. They've advanced so rapidly over the last decade or so. It's been crazy. So yeah, like I said, I would say start small, approach an expert, make sure you have a good plan, make sure you have a goal that you're trying to achieve, and that your plan is set to achieve that goal. And if you've had a bad first exposure, bad first experience with modeling simulation, I would say it's worth a second try. If it's been a while, even if it's not been a while, I think it's worth a second try. The benefits you reap from these virtual twins, these models, really outweigh the risks of running it a second time. So approach an expert, start small.
Good. I like it. Simple and straightforward. Prashant, what about you? What's your take here?
Alluding to what Brent said very clearly, start small and have your clear objectives and goals, right? What he's trying to convey anyway. Identify and map clear goals and objectives, what you want to achieve in virtual twins. And obviously, educate the workforce is extremely important, right? Train the business heads and IT managers, data analysts, and security teams, and even planners and even manufacturing engineers also to build and implement a virtual twin strategy. All their inputs is extremely important as an inclusive strategy. We need to bring in people on board. And obviously, the technology is there, invest in sensors and IoT platforms and supporting digital technologies to build a connected ecosystem. Obviously, somebody has to embark on it. And then we also have to have a data-driven analytical models as well. Invest in real-time data processing and a 3D modeling analytics and machine learning to build this model, even on the robotics and automation as well. So there could be like 5 steps. Once you can start to model your business process, you can develop a collaborative platform. You can implement a collaborative platform, which is easier to implement. obviously on cloud. And once you have a collaborative platform with all these lean principles, you can start to really optimize your business processes. What do you want to really optimize? Do you want to optimize manpower or machineries and materials and methods? All of them, and optimization, and eventually go towards systematic investment on IoT platform and analytical platform. And you can start to invest on your sensors and APIs and IoT platforms to get a real meaningful data accumulation in a real-time way, which helps in manufacturing operations excellence through these data-driven analytics or prescription analytics or AI-driven analytics to do day-to-day management of your manufacturing processes.
Okay, great, good. Thank you so much. Okay, so I think in this space we all have seen these great visualizations, these 3D models of cells, lines, whole facilities that are really compelling and really powerful. You can get a lot of value out of that effort, but not everybody has that as a starting point. Not everybody has a representation of their manufacturing environment. So when we talk about virtual twins and how do you get started, is developing kind of a comprehensive, complete kind of model of their manufacturing environment, is that a prerequisite? How does that play in to that? And Prashant, we're gonna stay with you. What's your perspective here?
See, 3D is still a luxury, right? People do talk about 3D simulation, 3D model and all. Obviously, for a lot of small and medium companies, 3D is still luxury. So virtual twins, obviously 3D, even though it's mandatory, someone can actually start their journey with, go lean before going digital, right? Bring in lean principles. There are a lot of lean principles you can start to adopt. And lean is not new. It's been there over 2 to 3 decades, and Japanese have started, and it's been being adopted everywhere. So go on lean, have a collaborative lean platform. You can actually start to share information, start to share data. Even it can be an unstructured data like loosely knitted, your spreadsheets and Word documents and PDF documents and all. Let's start there. And then even drawings, 2D drawings. As and when you start to build your 3D modeling core capabilities, it's not only the product, let's also try to build your manufacturing 3D models, like your factories, your machines, and your connected systems and all. And once that's there, obviously, you're on a great virtual twin journey, and you have your collaboration, you have your 3D model, and then obviously all the downstream processes would fall in place as and when the investment mechanism actually kicks in. So we do have the structure methodology to recommend, and then we also have great experience working in 12 different industry verticals. Chad.
Mm-hmm. Good, great, excellent. Arvind, what's your perspective here?
So, the journey has to be different for different companies because each company is at a different stage in their life cycle as well as their digital maturity. So that's kind of obvious. What do I recommend? I recommend companies to start where the impact will be maximum. The reason is you don't want people to lose confidence just because they have a setback. And as Brent said, looks like most people's first projects are not exactly success, right? I mean, and that's the reality. These are trial and errors, new technologies. People have to embrace certain failures along their way so that they eventually reap all the benefits of these kinds of technologies, virtual twin especially, right? So for a manufacturing company, over the years, the financial statement gives you all the key metrics as to how you perform relative to your peers, right? You can think of how do you do in terms of inventory? How do you do in terms of your cost of raw materials? How do you do in terms of your manufacturing costs? What is your marginal cost of production? All of this is well laid out. Any CFO in manufacturing company will be able to throw these numbers right out of her head or his. I mean, and I believe that's where people can first spot where should I attack the problem. If I do slightly worse than my peers in the industry, that's an area to focus because that's where your return on investment is going to be maximum. If my overall equipment effectiveness is not as good as what the industry peers are performing, then I stop that, right? Now, it's got a couple of advantages. First thing is buy-in from your senior executives is automatic, right? Because, hey, we do worst and all of our peers here, virtual twin can help in this regard. No brainer, right? Go ahead. You will be blessed straight away. And the second thing is the success is pretty contagious. The moment you show success in one particular thing, guess what? The other line managers are going to jump in to say, how can I improve? Right? So this 3D model is nice. Coming back to your question, it's amazing to have this entire 3D model, but I believe that there are better areas to target, at least when somebody is starting their journey. And so most companies will not start with modeling their entire facility in a 3D, on a virtual 3D. Most companies are going to look at areas where they can improve. And as Brent said, talk to expert to say, how can I improve my marginal cost of production? How can I improve my downtime? Tell me with virtual twin, what can I do? How to do that? And if that entails modeling a certain piece of your manufacturing puzzle as 3D, so be it. I guess that's easier to convince. And I believe that's where a nice starting point would be. And once that thing rolls on, I'm very sure the 3D will take its own form and the company will certainly get towards that.
Great. Good perspective. So we're talking about, do you need to have a full comprehensive 3D model of your manufacturing environment to get started? Brent, again, I'd love to hear your perspective from kind of the front lines. What's your take here?
Yeah. Do you need a full 3D model? The answer is no, you don't. You really don't. I guess it all depends once again on your definition of a digital twin. You can start with the physical data. You can start with what you have and the known information, the known data, and you can take a first pass and you can pass that data and create a little data model to help you better understand the process, understand your manufacturing abilities, that kind of stuff. And then you can use different types of sensors. You can make a smart product. That's something that's really taken off, is, make a 3D print of your product, or just make a model, or just put a representative and put some sensors in it and run it down the line. See what's actually happening, collect that data, use some type of sensor or smart product to fill some of those data gaps. And just collecting some of that physical data and creating a data model, or using some kind of a statistical analyses to have that first approach, get that first learning, is a good first step. You don't need a full 3D model. You can move into the 3D models and simulations to help fill some of those gaps, generate some synthetic data, like I mentioned earlier, to marry with the physical data and fill in the data gaps so you have a more comprehensive data structure. But you don't have to have it to start. There's a lot of things you can do on the front end before you have a full 3D model.
Good. Thank you so much. So let's wrap things up with some concluding points. Like, for those that are listening and watching the session today, what would be your main takeaways for them? Prashant, let's start with you.
The main takeaways are quite simple, and as we all have actually very well articulated in terms of value. Value is, the first and the foremost value is total cost of ownership, like lowering the cost and, improving the development, bring in agility and flexibility, optimizing time to market, especially during COVID disruption. We saw a lot of companies have completely changed their product lines, and how do we actually bring that into the market faster? And obviously increase safety being paramount, even during COVID as well. And then that's being considered in post-COVID. And towards net zero, reduce footprint, and ESG goals are some of our perspective, which we've been actually working on. And yeah, there's a lot of our customers have actually seen a reduction in overall time to market, increase in safety, and the reduction in overall cost as well, apart from productivity improvements and achieving ESG goals. So these are some of the things which we have seen in most of the manufacturing and operations industries.
Great, good, excellent. Arvind, do you have any key takeaways for folks that are listening and watching?
Certainly. Just one point I want to reiterate again is, identify that one area where you think you can have maximum impact. And certainly if you are wondering where you can identify financial statements, go back, talk with your CFO. He is or she is going to tell you that one area where you need to improve. Now, expertise is available. Solution providers like Dassault Systems, everybody, they have expertise. And as Brent said, there are experts in the field who will help you bridge this gap and will help you succeed. But you have to identify the area and you have to seek help. But rest assured, the help is available and people are there and the technology is there today to support your journey. That's my key.
Good. Yeah, thank you, Arvind. Brent, what about you? Any key takeaways?
Yeah, I would say 100% agree with what Arvind had just said. Have a straightforward goal. Know exactly what you want to do. Go back and run the math. If I have 3 hours of downtime, how much money are you losing in that 3 hours of downtime? You'll really quickly see the value of doing a lot of stuff virtually. You'll understand, it's important to just make that small investment in the first virtual twin. Like, find an expert, and I would say find an expert who knows how to do more than one type of virtual twin, right? Not just a computer simulation with stress analysis and that kind of stuff. Someone who can be creative and run VR, run a machine learning model, create data, that kind of stuff. Find someone who's going to be willing to be a partner and innovate with you, and really just have fun with it. Be creative. There's a lot of stuff you can do with these things, right? It's kind of boundless right now what you can learn from these types of models. So I would say just come in with that goal, come in with the known path, or find a plan for it and try it out. It's going to be well worth your time.
Great. Excellent. Yeah, I think that's really sound advice. Thank you so much. So that wraps up our session. Thanks to all of our presenters on the panel today. Really appreciate your time. Really good perspectives. And with that, let's switch over and take some questions. Let's get into that Q&A session.
Okay, thank you very much for being here. Now let's switch to the Q&A session. I see that there are already some questions asked in the chat. If you have some that you still haven't written, please feel free to ask them, and we will try to answer them. Of course, if we don't get to answer them, all of them right now, feel free to reach out to our experts who will be delighted to answer them. So the first question was the one from Nadia from Romania. Her question is, how much do we consider the virtual when considering the real project? And she gives an example. I created a project that was perfect as 3D, but in manufacturing needed some adjustments. I don't know who wants to take this one.
Yeah, I go. Thanks, Florine. This is what she's asking is as-built virtual model or as-built virtual twin. She did beautiful, the design model of it or a digital model of it. But when it comes to the as-built model, she needs to bring in the day-to-day elements of manufacturing processes. So this is where she may have like multiple methodologies. The first and the foremost thing is to really do calibration of her model, bringing in attributes from the real world through either discrete event simulation models or through the continuous update of her model through virtual validation. So we do have processes like assembly simulation, CNC manufacturing simulation, or robotic simulation. These are the things which really helps her to really update the digital model or the virtual model which she has created. That's first point. The second point is that while defining the plant layout, she can actually bring in the cloud of points, which is scan your complete factory or part of your factory, and then bring it back into the system through the cloud of points model, so that you can use the cloud of points to really construct your factory, so that your downstream simulations and applications will really help you to optimize.
Yeah, I'll jump in as well. I think I think this speaks to a matter of scope. Is kind of what's hinted at here. You could go off and create this grand, complete model, and we talked about how complete of a 3D model you need. I would suggest that when you start off, the scope of what you really want to focus on, at least initially, be small and very, very focused. So, and that way you can go through this phase where you attune physical and digital together and make sure that they match up, like, you know, what the attendee asked about. And you can refine that and make sure you get value from that first. So I think that question had some hints as to some other things in it.
Okay, next question. What do you see as impediments to scale virtual twins in the industry?
I'll jump in. Yeah, I'll jump in. So what do I see as a challenge there? I think, you know, I think one challenge is figuring out how much of it do you want to be like a physics-based, 3D-based approach versus what can be a data-based approach. You can use them certainly together. You can use them separately. And you're going to get value out of any of these approaches that you want to take. I think there are different companies that are trying to figure out which one do I go after first and how do I expand it over time. I think that's going to be a key question that companies need to figure out. So that's my take. I think that's going to be the biggest challenge. Oh, Prashant, you're on mute.
Oh, sorry. Added to that, few of the points like access to relevant data. You know, often there is no real-time data available, or only limited amount of sensors and other data sourcing points. And once you have the data, the lack of data standards and integration. You know, all of our customers, what we have seen, they have humongous amount of technologies and softwares, and few companies where we have worked with, they have museum of software. You know, they have multiple things, right? How do you bring in data and then have a meaningful outcome of those integrated data, right? You know, a lot of people have actually experienced difficulty in finding the right data available in a usable format. Can it be easily integrated into the data platform of the digital twin? That's one of the things which always you know, bothers and hinders the actual deployment of digital twin. And even once you have digital twin, accuracy of simulation. The major concerns at times troubles many companies who are keen on trying digital twins. Sometimes they doubt the regarding accuracy and outcome of the simulation and the technology they build. And sometimes, you know, once you have digital twins, how scalable and how sustainable they are, right? Most of the times digital twins are purpose built. This is where we articulated virtual twins, which are like, it's not unilateral or singular. It serves the purpose for multiple business processes. So you need to have an investment which serves multiple business processes or bring in flexibility and agility in the digital twins.
Yeah, definitely. That's 100%. You got it right there. I would kind of call it like almost a democratization of modeling simulation is where scalability starts to come in place. You know, you want to give these models to people who aren't experts in digital twins or in virtual twins. They're not experts in all these technology fields because you can't be an expert in all of them. And so there are ways you can go about, you know, automating and making these twins, these virtual twins, more accessible to the people who need them, the people, the business analysts, the machinists, the people who are designing the process, all the people who need to use them and use them on a daily basis. You can make them accessible and tailor them to what they need to see. They don't need to see, someone that may not need to see, you know, all the, you know, tolerances for this machine. They just need to see a few other inputs and know, like, if I enter these into this software or into this twin, I'm going to get some kind of output or prediction. That might be all they need. And so you can get into platforms where you can tailor those types of experiences and tailor it to the people who are going to use them.
Okay, thank you. Another question coming from Basil: how to ensure that the virtual model is able to match a real model? Real sensors can give you readings per milliseconds. So how do you decide how much matching is enough?
Yeah, it again depends. Sorry, go ahead, please.
Yeah, it's pretty much how much do you need, right? I'd like to draw a graph where, you know, on the y-axis you have complexity, on the x-axis you have cost, and as complexity grows, you get more and more validation, more and more detail, but so does the cost. It's going to grow, and it may grow linearly, it may not grow linearly. A lot of times it happens. You can get a lot of good complexity really cheaply, and then it starts to plateau and get really expensive for not a lot of gain. And so sometimes you just have to figure out, where's that plateau going to happen? What models I have to run? How validated do I need to be to actually solve my problems? And a lot of times you can get away with not pure validation, but just like directional results. You can say, this is what's happening today. I can see it. My virtual twin is showing similar results. If I now just update my virtual twin to what I want to do, make those changes, you can compare, well, the design 3 is better than the original, and directionally I know it's going to go in that direction. So I'm going to go with what I changed to design 3 because I know it's going to be the best. It's going to be better. So it all depends on how complex, how much physics you actually need.
Added to that, Brent, again, infrastructure requirement, right? You have humongous amount of data, data coming from machines, data coming from sensors, and all of them. Obviously, you need to have the right infrastructure. Are you going on a data lake or a data historian kind of a setup so that you can make a meaningful decision and outcome of those data collected? Just to give an example, in the mining company in Australia, they wanted data contextualized every minute. What type of data? They have these autonomous trucks which carrying all these raw materials in the mine. It's on the haulage routing. They wanted every minute update of multiple trucks, and at any point in time they'll have about 200 trucks, which has to be monitored in a central control and command center. And every minute update of data is actually needed so that, you know, they can actually track and trace usability and then productivity of all their mining operations. So it depends. Like mining companies want a minute. Process industries, where they may want every 5 seconds update of the data into their data lake or data warehouse, and manufacturing companies like anywhere between 10 seconds to 1 minute, depending on the takt time.
Makes sense. I don't have anything else to add. I think those are 2 great answers. So.
Okay. Next question then from Guy. What is the typical time it takes to create a virtual twin?
I'll jump in. I think, Brent, this actually relates back to the prior question. And I think Brent's answer related to that. The detail you want to go to should be driven by the value you want to get out of it. And the more value you want to get out of it, and this assumes there's a direct relationship between time and value you're getting out of it. I think that drives it, right? So it really depends on what you're trying to achieve.
Exactly, like engineering simulations and all, they may need very detailed information or detailed design information. But if you really want to do some manufacturing analysis or throughput analysis, you don't need an accurate 3D model at all. And it's like basic volumetric representation of 3D models are sufficient to really validate fast. You know, what is fast here? It's again an acronym. Fast is nothing but flow, accessibility, space, and throughput. If you want to do that, in a very minimal update of your 3D models are sufficient. But if you really want to do an accurate engineering simulation, flow simulation, or even simulations on CNC machining and robotics and all, you may need a fairly accurate model. It depends, like level of detail 100, level of detail 200, 300. There are various steps to really achieve it. But you can start your digital twin or virtual twin journey with the basic rudimentary 3D models.
Yeah, when you're first getting into like virtual twins, your first adventure in the virtual twin land, it's probably going to be the models you're going to create are probably going to be on an order of days or weeks, maybe a couple of months to build. Then you can start getting into like the big environments, like really getting huge benefits and returns, and expanding out into lots of different regions. Then you can get in like bigger and bigger virtual twins. I'll say things like months and years to build full-on platforms and full-on systems. But really, you're probably going to be down in the days, weeks, months, depending on how complex you want to be, like Chad said.
Okay, thank you very much. We have, I think for now, 2 last questions. First one from Eugene. Can we develop a digital twin model for CEOs to use daily do use daily? This is, I think, something that is also related to one of the previous question and answer you provided.
Yeah, I want to jump in there for latest project from Australia in Northern Territory, Darwin, where we created a virtual twin of a critical infrastructure of Northern Territories in Australia for one of the premier's office, like administrative head, who wants to use the digital twin for day-to-day management. It's called a stakeholder management. Any new critical infrastructure to be developed, they go back and then validate in virtual twin how to place it, what kind of implications they'll have, environmental impact, cost impact, manpower impact, and all. So it is actually used in one of the city leaders or one of the government officials' office for the day-to-day management of new projects.
Okay. And last question comes from Thomas. How do you handle ongoing revisions?
Oh yeah, that's pretty crucial. So I'll jump in real quick. Yeah, configuration of that is going to be really important over time. I think especially as you number one, try to do the initial digital representation and then match it to the physical. And of course, the physical is going to be changing over time. So how do you have the digital keep up and match what's happening in the real world? I think this gets into data management and lifecycle management, and that is a whole other domain that sits alongside modeling and simulation, but super critical. But you know, I will say this. This is where it gets really interesting with cloud solutions, right? So as companies like Dassault is leveraging cloud solutions, you naturally have to merge modeling, simulation, and data management together because you're not managing explicit files. That's handled for you behind the scenes. And that is kind of a natural advantage and benefit of using something in the cloud.
Okay. Then thank you very much. We don't have any more questions, so let's stop right here. I thank you all the speakers, of course, for their very interesting point of views, and to all the attendees who joined us and asked questions. And of course, feel free, as I said, to reach out to our experts for further questions. Thank you very much.
Thank you. Have a good one. Thank you so much. Stay safe.